notes and look at the starter question there. It says solve by completing the square. So we took a quiz on this yesterday. I already downloaded the scores for 8-1. Most people that did it did well. I'll put it that way. Okay. Amelia's laughing. Very nice. Go ahead and solve the starter question, please. We've done this a bunch, haven't we? A whole bunch. Hopefully we're good at it. Okay, I'm going to go ahead and get started. Hopefully you're well on your way. How am I doing so far? Does that look good? Okay. Didn't we solved? I think we solved this very problem, didn't we? Okay. So if you take a look at this, what I've added to both sides now, because this is an equation, it's okay for me to compensate on both sides. If I add 25/16 on this side, I'm going to compensate. I'm going to adjust by adding 25/16 on the other side. So this side is really easy. This just turns into x plus 5/4 quantity squared. And then over here I get a common denominator. So I'd need to multiply by 8. That's going to be a negative 8 plus 25. That's going to give me a 17 over 16. And that's not the greatest number because when I take the square root, I get x plus 5/4 equals plus or minus radical 17 over 4. Now this is nice that it turns out to have a common denominator. So when I move this to the other side, I get negative 5/4 plus or minus radical 17 over 4. I could leave it like that. I could write it as two separate pieces, or I could write it as one single fraction, negative 5 plus or minus radical 17 over 4. And there we go. Okay? All right, now we've done this a whole bunch. You've probably done 15 or 20 problems on your own. We've probably done a dozen or so in class, and it works the same way every time. We isolate the variables. We divide by the leading coefficient. In this case, it was a 2. We take half the middle coefficient. We got this number right here. We squared that, and we added that number to both sides. Then we took the square root, and then we got the x all by itself. So whenever we run into something like that, where we're doing the same thing over and over and over again, mathematicians like to do what we call generalize it. And if we generalize it, that means we do it without numbers in the problem. We just use variables to represent the coefficient of the x squared term, the coefficient of the x term, and then the constant at the end. And then we solve it just like we normally would, so just like we did above. And what will happen is, since it doesn't depend on what a, b, and c are, we're going to get a formula that will solve quadratics. Okay? So here's what we're going to do. I'm going to do exactly the same thing that I did above. First thing I did was I moved the constant to the other side. So we're going to have ax squared plus bx. Save room to complete the square. Move that to the other side by subtracting c. Whatever it was before, it's now the opposite on the other side. I don't want this to be an ax squared. I need it to be a 1x squared. So I'm going to divide everything by a. So I divide by a here, divide by a here, and divide by a there. And this is what I have now. I have x squared plus b over ax equals negative c over a. All I've done from the original problem to the step I'm at right now is just rearrange things. That's it. Just rearranging. Christopher, what's the next step in completing the square? Okay, divide by 2, or I said we're going to multiply by a half, and this is why it's much better to multiply by a half. If I take half of b over a, I get b on the top, and I get 2a on the bottom. I'm going to keep track of that because remember, that's going to be part of my perfect square. I'm going to take that number, square it, and when I square b over 2a, I get b squared on the top, and I get 4a squared on the bottom. Just like that ugly fraction right here, I get a perfect square of that fraction that I developed right here. If I add b squared over 4a squared to this side, I've got to do the same thing over here. So this is going to be b squared over 4a squared. Now you'll notice that the only thing that I've done to truly change this equation is this green stuff right here. I did the same thing on both sides. I made that adjustment, that compensation on both sides. Any questions? Okay, everybody watch, please. I can now rewrite this side right here. This is a perfect square of x and that number right there. So that was plus b over 2a quantity squared. I like writing the positive one first, so I'm going to write b squared over 4a squared and then minus c over a. Now, this is a bit of a mess. And you'll remember that I said most of the time this works out with a common denominator. Okay, we're going to make a common denominator on this one just like we did there. So I've got a 4a squared as a denominator here. I've got an a right here. What do I need? I need a 4a. So I'm going to multiply the top and the bottom by 4a. So this is going to give me x plus b over 2a quantity squared equals, I now have a common denominator of 4a squared, and the numerator is b squared minus 4ac. I'm now to right here. I've got a perfect square over here and a single fraction on this side. What was my next step? Take the square root of both sides. So if I do that, I get x, whoops, let me change back. I get x plus b over 2a, and then on this side I'm going to have a plus or minus. Now, you'll notice something nice about the denominator, and this happens every single time. What do you notice? It's a perfect square. So I'm going to write plus or minus b squared minus 4ac. That's all underneath the square root. And then if I take the square root of 4a squared, square root of 4 is 2, and square root of a is, square root of a squared is a. Any questions? Okay, so watch. If I move this to the other side, I'd do that by subtracting. So I would have minus b over 2a plus or minus big square root b squared minus 4ac. All of that's over 2a. And what do we notice about the two of these? I've got a common denominator. So let's write them down as one single common denominator, and I get this. I get x equals negative b, then plus or minus a big square root b squared minus 4ac, all of that over the single common denominator of 2a. This is the quadratic formula, okay? So we just found the quadratic formula. We derived the quadratic formula. That means that if you have an equation, a quadratic equation in this form where you've got all the terms on one side and a 0 on the other side, figure out what A is, figure out what B is, and figure out what C is. Don't worry about completing the square and doing all of this. Just plug B in here and here, A in here and here, C goes right there, and then just do the calculations. Okay? Now, I'm sure you've seen this before. Maybe you've actually derived it. Maybe you could derive it yourself, but I would imagine somebody in here knows a song that... yeah, I'm not going to sing it. Elaine wants to sing it?
Yeah, Christopher does.
It goes to, I've never heard it.
Yeah,
It goes to the tune of Pop Goes the Weasel. Elaine? Okay, that's not bad. I need you to sing into the microphone. Okay, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, there are a couple key things that we need to remember before we just plug things into this formula, okay? The first thing is you want to make sure you figure out a, b, and c correctly. This will not give you the right answers if you plug in the wrong things, okay? The equation has to be in standard form. That means all the terms have to be on one side and a 0 on the other side, and they've got to be written in descending order. If you grab them in the wrong order, you're going to get the answer wrong, okay? Now, once you figure out what A, B, and C are and plug them in, it's not that hard. It's pretty darn easy. The one thing I want to make sure that you're careful of is people make sign errors with the minus 4ac part all the time. So I wouldn't skip any work right there. So we're going to get that same answer we did up above. This is the starter question, only we're going to get it using the quadratic formula. So on this one, A is 2, B is 5, and C is 1. It's all in standard form. All the terms are on one side with a 0 on the other side. It's in descending order, so you can just pick them off. A, B, and C. So the formula says the answer is negative b, or the opposite of b. So that's going to be negative 5 plus or minus b squared. Now, a lot of people just do this. They'll write 25. I don't have a problem with that. If you can square b, it's always going to be positive when you square it. Then we're going to do minus 4. Please do not skip this part. Don't skip this. This is where people make the most mistakes. So this is going to be 2, and this is going to be a 1, and then the bottom is 2 times a, so that's going to be a 4. Please don't skip any more work than that. Okay, then the next thing I would recommend doing, and you don't have to do this, but I would do it if you want to make sure you get the answer right. Look at this stuff underneath the radical. This is where the most mistakes occur. I've got 25, and then look at this number. Am I going to be adding something or subtracting something? I'm going to be subtracting because there's only one negative. I'm going to be subtracting 4 times 2, that's 8. So here's what I get. Negative 5 plus or minus 25 minus 8 is 17 all over 4, and there's the answer. It's the same answer we got up above here. It's sitting right there. But look how much work it took to solve it by completing the square, and look how easy it was using the quadratic formula. But again, you've got to plug things in right in order to get it correct. Please don't forget that this does actually represent two answers. One of them is negative 5 plus radical 17 over 4, and the other one is negative 5 minus radical 17 over 4. So you still can break it apart and represent those two answers separately. Okay, are there any questions? Elaine, you want to sing that again? Okay. Can you tell me what's wrong with this one? It's not in descending order. So we're going to rewrite it like this. 5x squared plus 8x. And the other problem is it's not equal to 0. So I need to move that over to the other side. If you were to plug in a positive 3 for c, you're going to get the answer wrong. So here's what we've got. Negative b, so opposite of 8, plus or minus. This is going to be, I'm going to write this down here just a little bit. Negative 8 plus or minus. This is going to be 64 minus 4 times a times c. So I'm going to plug in a 5 and a minus 3. That's all over 2a, so that's a 10. Any questions there? This is 64. Am I going to be adding or subtracting? I'm going to be adding because there's two negatives. So I'm going to put a plus here, and then let's figure out what that number is. This is 20. So that's going to be 60. So this is going to be negative 8 plus or minus square root of 124 over 10. I do need to simplify. It's not like the answer just drops out and here you go. Plug it in and you're done. So this is going to be negative 8 plus or minus, let's see, 124. 2 goes in there 62 times. 2 goes in there 31 times. Is that right? 2 times 2 times 31, and 31 is prime. So this is going to be 2 radical 31 over 10. And does anybody notice anything I can do here? Okay, technically this is what you should do. You should factor out a 2, and I'm left with a negative 4 plus or minus radical 31 over 10, and then cancel this and make that a 5. The short way to do this is to take each one of these 3 terms and divide it by 2. So that's negative 4, that's plus or minus radical 31, and that's a 5. There's your answer right there. I'm okay on this one for now. If you leave it as 1, if MathXL wants it as 2, you better make sure you write it as 2. Any questions? Okay, so let's talk about the techniques that we have for solving a quadratic, for finding the solutions to a quadratic. If there is a perfect square, all you have to do is isolate it and then take the square root. So we can use the square root property to solve it. If there's not a perfect square, we can write the equation in standard form and factor it if you can. So even on these problems right here, if we could factor it, that might be easier than using the quadratic formula, okay? If neither of those methods work, then use the quadratic formula. Okay, now why isn't completing the square on this list of 3 things we can use to solve a quadratic? Because you can complete the square to solve a quadratic. That's what 8.1 was all about. Yeah, the formula is completing the square in general. So why bother completing the square if we already did that in general and we've got the quadratic formula? Okay? Now, that's not to say that you're never going to get instructions that say solve this by completing the square. And that's definitely not to say that solving by completing the square is not a useful skill. It is. We use completing the square all the time. You're going to use it in 1050. Okay? I will probably ask you one question on the test where it says solve this by completing the square just to make sure you haven't forgotten. Okay? All right. But again, the key there is see if one works. If it's already got a perfect square, take the square root. You're almost to the answer. If not, see if you can factor it. And if it doesn't factor easily or solve by taking the square root easily, then we'd probably want to do it by completing the square. Okay? So let's take a look at the next side. And let's use our head. It says solve using an appropriate method. So that means use anything you want. So should we just start plugging into the quadratic formula? First thing we ought to do is let's see if it factors. Are there numbers that multiply to be negative 4 that combine to be negative 5? Multiply to be negative 4 combined to be negative 5. Answer there is no. Okay? If it were positive 4, then we could do that, but it's not. So does this factor easily? It doesn't factor easily, so let's go ahead and use the quadratic formula. So that's going to be 5, opposite of 5, plus or minus, there's the b, square that. So this is going to be 25, minus 4 times a times c. Please don't skip that step. All over 2 times a, so that's going to be a 2. A is 1, c is negative 4. And again, please do the arithmetic up here. Please do everyone a favor, including yourself, if you want to get a good test score. This is 25. Am I adding or subtracting? I'm going to be adding. I'm going to be adding 16. So this is 5 plus or minus radical what? 41 all over 2. Now, 5 plus or minus radical 41 over 2. Is that a nice answer or an ugly answer? I think it's great because you don't have to do anything else with it. Doesn't simplify at all. End of story, that's the answer. No way you'd get that by factoring. Let's look at this one. Tyler, what's wrong with this? It's not in descending order, and it's not set equal to 0. So we're going to put 9x squared plus 30x, and then this is plus 25 equals 0. Take a good look. Even though the quadratic formula is pretty quick, if you know the formulas we went over in the last couple chapters, you're in much better shape. Is that a perfect square? Perfect square of 3x. Is that a perfect square? Of 5. Multiply them together. That's 15x. Double it. Is that the right middle term? Yes, it is. That means this is a perfect square of 3x and 5, quantity squared, Plus or minus? Plus. What's the solution that comes from this factor? Opposite of this, divide by that. So the answer is negative 5/3. If you want to plug into the quadratic formula and use an a of 9, a b of 30, which when we square it, by the way, would be 900, then do minus 4 times 9 times negative 25, and put it all over 18, because that's what 2a would be, you will get exactly the same thing, but it's a heck of a lot easier if you know those factoring formulas. Get the point? Okay, let's take a look at the next one. It's already in standard form. It's set equal to 0. It's not a perfect square. But does it factor? Yeah. It does factor. Okay? Now, this is a difficult trinomial. You'd have to find numbers that multiply to be 6 that combine to be negative 7, and then you'd have to do grouping to figure out which one goes where, or you'd have to be good at guess and check. So this would be 3x. This is going to be a 2, and this is going to be a 1. Those are both negative because they'll multiply to be a positive. Negative 1x, negative 6x, that's the right term. So the answer here is 1/3 and 2. Those are the two answers. Now, if you use the quadratic formula, opposite of negative 7, so that's going to be 7 plus or minus b squared, so that's going to be 49, minus 4 times a times c, so there's a 3 and a 2, all over 6. Again, be careful here. This is going to be 49 plus or minus? Minus. That's going to be 4 times 6, so that's 24. Lo and behold, look what happens. 7 plus or minus radical 25. 7 plus or minus 5 over 6. So again, this is the cool part. You do need to practice writing these as separate pieces because this one's going to be 7 plus 5 over 6 and 7 minus 5 over 6. This is 12 over 6, which is 2. And this is 2 over 6, which is 1/3. Correct answer, just got a different way. Any questions? Yeah. Good? Sure? Okay, let's take a look at the next one. Sid, what do I need to do here? Okay, so we're going to move the 1 to the other side, so t squared plus 4t minus 1 equals 0. Factor? No way. Multiply to be negative 1, combine to be 4, that won't work, so we're going to do negative 4 plus or minus 16 minus 4 times a times c, not skipping that stuff I told you not to skip. The bottom's a 2. I plug in a 1 here and a negative 1 here. $16, and we're going to add. How much are we going to add? We're going to add 4. So 16 plus 4. So my answer is going to be negative 4 plus or minus square root of 20 over 2. Do I leave it like that? No. Nope. This is going to be 4, negative 4 plus or minus. Let's see, that's a 2 and a 5. Easiest way to write this, easiest way to get the answer, take every one of the 3 terms here and divide them by 2. So that's going to be negative 2 plus or minus radical 5. Wait a minute, what's the bottom now? A 1. Do I need to write it? I don't. That's the answer. Notice how those are conjugates. If I write those separately, negative 2 plus radical 5 and negative 2 minus radical 5. That's going to happen every single time on a quadratic. Your answers are going to be conjugates. Any questions? Okay, would you solve 22 and check with your neighbor? Is there anything good about this problem? Wow, overwhelmingly no.
He figured it out.
When you're done, or I suppose when you get stuck, check with your neighbor.
Yeah. So it has fractions, roots. Yeah, let's just throw everything that we don't like in
Well, at least it's in descending order.
there.
It's set equal to
These are all
0.
positive.
So this is going to be -1 plus or minus. 1 squared is 1 minus 4 times a times c. So that's going to be a 1 times 4 all over 2. And then again, I focus on this right here. I'm going to take 1, add or subtract. Subtract 16. So that means I have -1 plus or minus radical negative 15 all over 2. -1 plus or minus I radical 15 all over 2, and that right there is the answer. Now, you should be able to write it as two separate pieces, and in fact, that's actually important when we're dealing with complex zeros, complex solutions, complex roots, complex x-intercepts, we can call them. Okay, this would be -1/2 plus I radical 15 over 2, and -1/2 minus I radical 15 over 2. This is the real part. Notice the real part's the same on both of them, and this is the imaginary part. Notice that it's a different sign. So remember, these are, just like before, these are conjugates of each other. Any questions?
Question.
Yeah.
So couldn't you write like two different equations, but could you just do like 1 plus I root 15 over 2, or they have to be two different separate equations or twos?
You mean, could I put just a plus or minus here?
Yeah.
Or what? Yeah, I could. Yeah.
I was just wondering why you
So
split them up.
So what I've done here is I've broken it into two pieces, so I can tell. Remember, we had a plus bi. That was the form of a complex number. The real part is right here. It's -1/2. The imaginary part is this right here.
And is the I over the 2, or is it just out front?
I put it out front, but it doesn't matter. You can put it over there.
So it's just like a negative.
It's a multiplication problem. You can't put it on the bottom
Yeah,
though.
other than the bottom.
Okay. All right. Any questions? Okay, take a look at the next one. What's the easiest way to solve this one?
Factoring.
Can you factor that?
No. Wait.
Sum of squares?
Dang it.
There is no sum of squares, but this is one single perfect square, so I can move this to the other side and then take the square root. I get x equals, what do we put when we put a square root in the problem? Plus or minus. And what's the square root of -9? 3i. So there are the two answers. One of them is 3i, the other one is -3i. Okay? So two solutions to that one there. I've broken them apart and written them separately. I could write it as a conjugate though, complex number, 0 plus or minus 3i. They're still conjugates, still equally spaced around 0 in that particular case. Any questions there? Okay, let's look at the last two because you do have some problems that are set up like this. This is a little on the ugly side. The big problem here is we don't even see any squares yet. So we're going to distribute through 5x squared minus 5x minus 7. There's a quadratic right there. But look on the other side. This is 4x squared minus 8x. This is a quadratic. So you can solve it by any of those techniques we talked about. Let's move everything on the same side first. That's going to be minus 4x squared. That's going to be plus 8x. So here's what I've got. X squared plus 3x minus 7 equals 0. Is there any way that factors?
No.
Will not factor. So immediately you'd start plugging into the quadratic formula. I'm most interested in what you come up with underneath the radical. So would you figure that out really quickly, please? Is it positive or negative? It is positive. So we're going to have 9. We're going to be adding 28. So that's going to be 37. Negative 3 plus or minus radical 37, 37 over 2. And really, that's not that bad, is it? It's almost nice when they're that ugly. If you've got a prime number underneath the radical, because really there's not much you can do with it. Okay, let's take a look at the next one. And, okay, can I blow this up a little bit? Tyler, question?
Just with the denominator, it seems a bit weird.
The 2? What do you mean?
Maybe it's just me. Don't you plug in the A?
Yeah.
Yeah, what's A? A is 1. Bottom's 2A, 2 times A. Okay.
Double whatever.
Okay. Good? Okay, let's take a look at the next one. You do have a couple problems like this, and these are very good review problems because they go over how we solved rational equations in the last chapter. Let's see. Do we want to be careful at all?
Yes.
We do. What do we have to be careful of?
Can't equal 0 or -4.
Okay, we have to be careful whenever we've got division, even roots. In the next chapter, we're going to learn about logarithms. Anytime you have one of those operations or one of those functions, you've got to be careful because I can't divide by 0. And what would make this one? -4. So I better make sure that the answers are not 0 and -4. If they are, I throw them out. Okay? So if I solve this problem, the first thing I'd want to do is multiply by something that will cancel off the denominators. So that's going to be x and x plus 4. So what do I get on this side? Do I get a 1? Okay, I get the x and the x plus 4. Over here, the x cancels, so that's 7 and x plus 4. I'm just showing all the work if you don't mind. That's 7 and the x plus 4 canceled, so there's just an x left. So this is now like the problem that we did just a second ago. Let's distribute through. X squared plus 4x equals 7x plus 28 plus 7x. Move everything on the same side. Now, even though I have to move 3 terms, I suppose, you're better off moving it over here to keep the x squared positive. So we're going to subtract 14x altogether, and we're going to subtract 28. So that'll get rid of all of these. So I've got x squared minus 10x minus 28 equals 0. And it would be really nice if that factors, does it? It doesn't. Okay, I like that response. Of course it doesn't. Okay, so we get 10, because we take the opposite of b. Everybody doing okay there? 10 squared, that's not too bad. That's going to be 100. 4 times a times c. Again, careful with this. That's a 1, and that is a negative 28. All over 2 times a, so that's all over 2. We're careful here. This is going to be 100 plus 112. Is that right? 4 times 28, 112. Negative times a negative is positive there. So this is going to be 10 plus or minus 212 underneath that radical all over 2. And then I'd want to simplify that. So let's see. 212. 2 goes in there 106 times. And 2 goes into that 53 times. So double check me there. Is that right? 53. Let's see, does anything go into 53?
Maybe. No.
I think it's prime. So 10 plus or minus 2 radical 53 all over 2. Easiest way to write the answer.
5 plus or minus radical.
And notice, those are conjugates. One of the answers is 5 plus radical 53. The other one is 5 minus radical 53. These two numbers are equally spaced about 5. So if 5 was sitting right here, I'd go radical 53 this way to get to this answer, and I'd go negative radical 53 to get to this answer over here, but they'd be equally spaced. Any questions there? Okay, let's take a look at the last couple. These are repeats of problems that we've already done. So all I need to do is look up above here and figure out, well, this was number 8. That one right there. Let's see if the quadratic formula, this right here, would give us the correct answers. And we're going to do these on a calculator. Same with number 12. Okay, so let me write down what this one was. This one was 7 plus or minus radical 25 over 6. Number 12 was negative 2 plus or minus radical 5. And this one was that last one right there, so I'm just going to make this a little bigger and we'll go from there. Okay. So grab your calculator. What?
So,
Did I write it down wrong?
well, number 8, if we look back up there, didn't we get 2 and 1/3?
We did.
So, oh, that's the unfactored. Never mind.
Okay. So I'm doing this for a reason. This has nice answers. The calculator definitely ought to be able to produce these. If I'm going to type this into the calculator, don't say anything out loud. What do I need to do first? What do I...
Sorry.
That was Zach Albert, everybody. Okay. I do need to start with parentheses because you'll notice I have more than one term on the top. So I'm going to do parentheses. And you can do this on those TI calculators as well. So I'm going to do 7 plus, and then I'm going to do a square root, 25, close the parentheses, close them again, and then divide by 6. Now I can only do one at a time. I'm going to do the plus one first. There's my answer of 2. On your calculator, you can just hit the up arrow. On mine, I have to recall that command so I can edit it. The only difference between the two answers is the plus and minus. So I'm going to change that to a minus. If we did this right, what answer should this spit out? 0.33. On your calculator, you can change it to a decimal. On this one, I'm going to hit math. Change that to a fraction. There's my 1/3. Okay? Okay, let's do this one, and we're going to write down the answers accurate to 3 decimal places. So on this one, you wouldn't write 0.3 repeated. You'd write this, and you'd write the other answer of 2. Okay, let's do this other one. I'm going to slide this over here. I'm going to type this into the calculator. So we've got negative 2, plus radical 5. Close the parentheses. There's my first answer, and accurate to 3 decimal places, it's going to be 0.236. There's the first one. That's the one when we add radical 5. So here's negative 2. If I add radical 5, I get to right here, 0.236. Okay, if you go on in math, you're going to be able to use a calculator a little bit more. Okay, but you do need to know what to expect when you plug something into your calculator. So I'm going to take negative 2 and I'm going to subtract radical 5. What type of number am I expecting? A negative number, and it better be bigger, I suppose, if you want to think of it that way, or smaller, more negative than negative 2. So I'm going to recall this. All you have to do is hit the up arrow and change that to a minus, negative 4.23. And there are the 2 answers. Those are called decimal approximations. Okay? And then we can do the same thing on this problem right here. I can grab those answers. Let's see. So that was 5 plus radical 53. So one of the answers is 12.28. That was a 0, right? 12.280 would be accurate to 3 decimal places. There's one of them. And then the other one, I just recall that, and I change that to a minus. So we're doing subtraction, and I get 2.28. Oh, yeah, it was negative. Thank you. Okay. Any questions? Yeah.
So when we try to put it in decimal form, we were supposed to have the same decimal place. I think.
I would say I think 3 decimal places is pretty darn accurate. Okay. Anything else? Okay, watch. Just watch. Okay. Remember, the whole point of solving this is to make the equation true. So if I take that number right there, if I take 0.236 and I plug it into this one here, it should make the equation true. So if I take that and I square it, then I add 4 times 0.236. What should I get if this made the equation true? Zach, what did you say? About 1. Why am I going to get about 1? Okay, because I rounded. I'm going to get something close to 1. That's pretty darn close to 1. Watch what happens if I recall I recall that one right there. Now, this is stored in the answer. What happens if I take the answer and square it? So it's that big ugly decimal squared, and then plus 4 times that answer. Now, it stored this ugly decimal in there. It's going to square it and then add 4 times that ugly decimal. What should this give me? Exactly 1. Okay? And you can do that on your calculator also. It's got an answer button. It's right here. It's above the negative. Second and the negative gives you the answer. Last answer that was stored in the calculator, that is. Any questions? Sure? Have this done. Get this done today. Go home, get it done. If you've got a break right now, go get it finished up. That way when you walk in here on Monday morning, you're all caught up, done. You don't have to worry, oh crap, did I do that over the weekend? Okay? Have a nice week.